Alright, I'm switching over to LeetCode for a little bit. Wanted to give them a try. I've been doing quite a few HackerRank problems lately, but wanted to see what LeetCode had to offer. So I found something about some top questions and a chapter. I guess they organize into chapters about like arrays, strings, trees, and this one is about finding the depth of a binary tree. So given the root of a binary tree, return its maximum depth. Binary tree's maximum depth, the number of nodes along the longest path from the root node down to the farthest leaf node. So it sounds like a depth first search and um, maybe some recursion in the depth first search, and then you return the max depth that we find. Input root equals what? 3, 9, 20, null, 15, 7. I think that's what it is. I think that's what it's saying. Well, you could probably game this and just, yeah, yeah. you could game this, I bet, and just go off of how long the array is. Yeah, 1. So the length minus 1 divided by 2. And I bet that'll give you your max depth ceiling of division by 2. So if you take that off and then that's 3. Yeah, bet I bet you could game it, but I'll actually try to write out the algorithm because I'm curious about that. So we have root, and then let's put this into make this into a tree. I guess a graph of sorts. So we can do a map of this. So tree is going to equal this, and then from the tree, I forget what the term is that people use to describe this kind of method, but more or less we'll do something like, so for this first one, we'll have 3, and then the children are 9 and 20, and then we'll have 9 and what is it in Python? Thought it was null. Maybe it is, and the syntax highlighting isn't picking it up, and then 20 would have 15 and 7. So that's what I'm going for, more or less. So I'll take the tree and then I'll parse through. So we're gonna have it's gonna be weird to like parse this stuff out, but tree. Oh, aha! Is it already? Yeah, it's already parsed out for us. Okay, well that's nicer. Definition for a binary tree node, and then is that real? Okay. Max depth. We're going to do. So we'll need to recursively look for the max depth on the left and the right. I'm going to do max depth and make it equal 0 from the start, because I'm guessing that this is going to be called by whatever is called in this. I don't know how they set this stuff up. It's a little clearer in HackerRank. Like I said, I've never done LeetCode before. I literally just signed up for it. So we're going to do a max depth on this. And for depth first search, you can recursively look through each node or each child. So in this case, just left to right because it's a binary tree until there are no more children. And when there are no more children, you would return, and that would propagate everything back up. So we would look for left and look for right, find out the depths on each one of them, and then return those. So um, max depth. Okay. So we'll look for left. We'll call max depth on root dot left. So that will be and then max depth for whatever we have. Actually, we might not need max depth. So if we did this, max depth on root left, max depth is equal to that, and right max depth is equal to that, and then we'll just take the max of those two. If we want to get to a point where if not root dot left so if we've hit the bottom if there's neither a left root or a right root or a right child. So we want to return so I'm thinking if we go all the way down, then we'll propagate the return up. So we want to return 1, and this would only ever return 1. We have to add somehow. We have to add in all of the ones that get returned. So we're gonna go nothing, return 1 here, return 1 plus 1 here. So here we do plus 1. So we want to return the max depth plus 1 because here we're adding on. So we start with 1 when we hit the very bottom. So 15 is 1, 7 is 1. So that's 1. That returns up. So this will be 1 and this will be 1. And then 20 will return 1 plus 1. Or either it's the max of 1, 1, which is 1 plus 1. And then it's just, yeah, and then it would just continue. So I guess this we would only want to do left max depth if there is a root left. So if root dot left, and then if root dot right. I'll be honest, I don't know if this is the correct syntax, if this works with Python. I don't like this editor thing. I got to change this real quick. I don't know if this syntax works with Python, but we're gonna find out. Oh. Oops, I don't know why. I thought I had deleted that, but I guess not. Alright. Max depth. What? Oh, okay. Self dot. Huh. Okay. Well, so it passed our first one. Is this it? Do I only get one case? Okay. Submit it and see what happens. Runtime error. Ah. So it's only if it is there. So let's go ahead and define these as 0, and then either, well, it'll return 1 if it's done. I guess you just make these 1. In effect, doing this is the same thing as having if nots beforehand. Because if they aren't there, then we're at the end. But if there's another one, if we recursively found another one, another level, then we would continue on, and that would be the new max. So I think, yeah, this works as well. At least by the same thought. Visualize. I output 4. Oh, did it not even run the... What? I'm very confused by... What? Okay. I'm a little confused by that. So if it's... it would go... Nothing, nothing. Then it would hit this. Couldn't find either of the children. So it would return 1 plus 1. Ah, yeah, that was the problem. This plus 1 is what gives it the initial 1. Otherwise, it's 0. Okay. Yeah, that was my fault. I didn't think through that correctly. Is this how... Yeah. Then type has no attribute left. Huh. Okay. Okay. But it's... I guess what it's trying to catch is that edge case where there's nothing in the tree. So... But there is no what? How can you not give me... It's supposed to be a tree node, right? So it should have a left. You're saying that root does not exist. Well, I don't like that. I don't like that at all. Okay. Well, I guess we'll try catch it. That's a little annoying that they tell us that it exists there, and it would be none if it's not an actual value, but here we are, and apparently we can't reference left, so what's the, oh, okay, I guess it has two different things. It has the run and then it has a submission. Ah, I output 1, it expected 0. So if there, what? I, that one's annoying. That's such a weird edge case. If it passes me nothing. I guess if it passes me nothing, I would just return 0 because that means that isn't a tree. It isn't a valid tree node. And if it's not a valid tree node, then I can't traverse the tree. I don't like that edge case. That was weird. Well, I guess that went through. It accepted that. Well, that's cool. So it shows the runtime distribution, some memory distributions. So I used a little more memory than others did. Huh. All right. Well, I guess that's how you do LeetCode. Yeah. Thanks for watching. I'll probably be doing some of these other LeetCode ones in the near future, just to get some extra type of practice that's not only hackering. So thanks for watching.